Welcome to the video for 4.4. This is the second video and I'm just doing examples 3, 4, and 5 and then some of our examples on our own. This is starting on page 298. We're starting with representing functions at the top here. It's our key concept. We have words, equations, tables, ordered pairs, and a graph. We know that words we can turn into an equation, and we can take this equation and make a table with x values and y values, put those into ordered pairs, and then we can graph it. So all of these represent the same function, just different ways to show them. Now here we have some linear function is not brand new, but two other ones that are. So if we look, it says a linear function is a function in which the graph of a solution forms a straight line. That should not be new. Remember, linear means straight. Therefore, an equation in the form of y equals mx plus b is a linear function. So if you have an equation that looks like this, y equals mx plus b, or even if the b is not there and it's just y equals mx, that is linear. Now we have two new vocabulary words, continuous data and discrete data. So continuous data is when you can take on any value, so there's no space between data values, and then discrete means that you do have space. And I'm going to show you different examples of what that means because sometimes these definitions don't make sense. Here's your takeaway from that. Continuous means that it is a connected line. So there's been times in the past where we do connect a line and don't connect a line. Now we can put a name to them. Continuous, you can have a connected line, which means you can have values that have decimals and fractions. And then discrete, it can only be a whole number. So you can't have partial of something. So when your answer, your y value, your f of x, if that's your function, then your answer is not going to be, when you're on discrete, it's not going to be a fraction or decimal. And that makes sense in certain cases, like if we're talking about how many people are in a room, and let's say that the answer is 5. Since it's a whole number, that data is going to be discrete, and it also makes sense because you can have part of a person in a room. All right, here's our first example, number 3, which is at the bottom of page 298. It says each person that enters the store receives a coupon for $5 off his or her entire purchase. Write a function to represent the total value of the coupons given out. So we can have y represent the total value, so we know y is our answer, is equal to 5 times x, where x represents the number of people. So every time one person comes in, they get $5 off. Another one comes in, there's $5. So depending on how many people, which is our x value, that's how many total coupons are given out. Now, number 4 on 299, it goes with number 3. We had that equation y equals 5x, and they want us to make a function table, and they even give us the values here. And we're given 5, 10, 15, and 20. So those are our x values. Those are what we plug in first, 5, 10, 15, 20. And the reason they're being plugged into 5x, remember, because that's our equation. So instead of having an x right here, you plug in all of these x values. So I have 5 times 5, 25. 5 times 10 is 50, 5 times 15 is 75, and 5 times 20 is 100. So that function table is complete. If you take a look at number 5, now they're asked you to graph the function and then explain if it is continuous or discrete. So graphing the function, your first ordered pair here, we're at 525, 1050, 1575, and then 2100. And they even already have it labeled for us. Now, right here, there can only be a whole number amount of customers. So I'm going to flip back to the table at the top here. Notice how y, our answers, are all whole numbers. When they're all whole numbers, that means that it is discrete. And remember, discrete means not connected. Because if we connected these, and that means that all of these answers in between are possible answers, which doesn't make sense when you can't have part of a person. So number of customers, and then total value of coupons. None of that was a fraction value. Okay, let's try this one, and this is at the bottom of page 299. It says a store sells assorted nuts for $5.95 per pound. Write a function to represent the total cost number of pounds. And we'll do this on D. So we can pick our own variables, but we know it should always look like y equals mx, where m is our slope or rate of change, however you want to think about it. So we know we have a function and we want to know total cost. That's going to end up being our answer. So my equation starts with C equals, and then right here we are looking at sort of nuts per pound. So I'm going to be doing 595 times however many pounds of nuts I have, and I'm just going to put P for pounds. So here is your function. C equals 5.95P. Now they want you to complete the function table below to find the total cost of 1, 2, 3, 4, or 5 pounds of nuts. So this is where we're at on E right here. We're going to do it on this table. So this one represents all of my P value, the number of pounds, which they give me as 1, 2, 3, 4, and 5. And in the middle, that's where we write the equation we're going to be using, which is 5.95 times P. And then the output, which is our answer, is going to be the total cost. So right here in the middle, I'm going to be doing 5.95. And I'll type this out so we can see it easier. On the first one, it's 5.59 times 1. And we can write that like that, if we could see it. So since this is on our notes, if you'd like to be lazy and just write in, or just do the arrow, that's fine too. All right, so the answer for this one's going to end up being 5.95. Guess we're on white here. So we're going to go ahead and finish filling out this table. And like I said, we can do it the lazy way, that's fine. You just need to know that, okay, I'm taking 5.95. I'm going to take it times 2 for this one, and then 3, and then 4, and then 5. Right? And then all of your answers after you multiply these are going to go right over here. So this first one, let me just copy and paste this. This first one, or the first one's 595. When you do 595 times 2, you get 1190 for 2 pounds of nuts. And then when you do 5.95 times 3, you're going to end up with 1785. Next one, when you do 4 times 5.95, you're going to get 2380. And then the last one here, 5 times 5.95, gives me a total of 29.75. Now, on F, they want us to graph the function, but before we can graph it, we have to fill in our values here. So the X value, which is everything we start with right here in the first column, well, we know that P stands for pounds. So you can fill that in for this one right here. So that means our output that we're getting, the C right here, that represents the total cost. And we will turn that so it can fit into our graph. And then from there, we're just going to plot our points. And where can I find my points? Right here. The first one is 1, 5.95. So I'm going to estimate I go over 1 up to 5.95, just barely. Now this other one, I have 2, 11.9. Go over 2, up 11.9. The third one is over 3, up 17.85. Fourth is over 4, up 23.8. And then the last one is over 5, up 29.7. 75, that is, right there. All right, so now we need to figure out, is it discrete or is it continuous? Which means, should I connect my line or not? Well, since I already know that these have a decimal value, remember, a decimal value means it can be connected, and they're not completely straight. They should be, but they're approximate. If it's connected, remember that it is continuous. So I'm going to explain it underneath. If you have room to the side, you can. Underneath F, I guess we can move this over there. So our explanation, we're going to say continuous, because remember, continuous means that the line is connected. And it also means, one more thing, continuous. I got to change my font color. Sorry about that. Continuous, because the line is connected. And we know this because there are decimal values. Remember, continuous line is connected with decimal values, decimal fraction, whichever one. And we are going to start on some of our practice problems now.